Well, greetings, my sweet fizzheads, and especially Megan. So we're given, in this problem that you asked about, which is problem number 1 on the rotation assignment, we're given a wheel that's free to rotate on an axis, but the axis is not frictionless. And then they tell us about a first event. So there's a wheel which is initially at rest, undergoes a constant external torque, which is applied for a short time period. And they give us those values, so 55 Newton meters for the external torque, and it's constant again, and the time period is 20 seconds. After that time, the wheel has an angular speed of 650 revolutions per minute. Note that we'll want to convert that to SI units. Then, what I'm calling event number 2 happens, and the external torque is removed. The wheel comes to rest, so that final speed will be 0 after another short time period of 120 seconds. So for this problem, we are supposed to find the rotational inertia, or moment of inertia, for the wheel. I'm labeling that I sub W. And also the torque due to friction from that axis. Again, I'm labeling that tau sub F. So the plan, as always, is to find some connection or connections between the given information and what we're supposed to find. In this case, those general rotational kinematics equations and our Newton's second law for rotation, I think, will be most useful. So I wrote down a couple. I said the time invariant version, which is energy related. The final angular speed squared is the initial angular speed squared plus twice the angular acceleration times the change in the angle position. Okay, and then the one that we're actually going to end up using for the kinematics equations is that the final angular speed is the angular acceleration times the time that's applied. This is for a constant angular acceleration situation, plus the initial angular speed. And then, of course, Newton's second law for rotation, the net external torque is the moment of inertia, or rotational inertia, times the angular acceleration. Page 3, where we have the calculations and analysis. So from event 1 and then Newton's second law, the net external torque includes both that applied external torque that they gave us at 55 Newton meters, plus the frictional torque. The sum of those two external torques would equal the moment of inertia of the wheel times the angular acceleration during that first event. Now we can find the angular acceleration using the kinematics equation. So we do the unit conversion that I mentioned earlier to get 65 pi over 3 radians per second for the final angular speed. Of course, the initial angular speed was 0. They told you the time was 20 seconds. And so you can solve for the angular acceleration while that external torque was being applied. And I got 13/12 pi radians per second per second. Then from event 2, now there's just that frictional torque. And it will equal, this is Newton's second law for rotation again, the angular acceleration times the moment of inertia. Now, because they gave us some information about how long it takes for the wheel to come to rest, we can solve for the angular acceleration during this second event, where it's just the frictional torque that's slowing the wheel down to rest again. and we find the angular acceleration is negative 13 pi over 72 radians per second per second. Okay, so using the angular acceleration for event 2 and substituting that in, we can substitute for the frictional torque in that first equation from page 3, labeled equation number 1. And that allows us to solve for the rotational inertia. You can take a look at the arithmetic fun I was having. I like working with exact numbers when possible. So simplifying things at least a little bit, we would get that the rotational inertia is 55 times 72 over 91 pi. And that's just for the numbers that were given to me when I looked at the problem. In WebAssign, your numbers will be different, so I'll let you work out the arithmetic yourself. But hopefully you'll see that your basic question, Megan, was why are they adding this rotational inertia times an acceleration? Well, that came from kind of calculating that frictional torque in terms of the rotational inertia of the wheel and the angular acceleration during event 2. So it was that substitution. That's why you saw I alpha show up again in the equation that you were looking up on using the Google Brain. So hopefully that explains it. If not, let me know.